Okay, so in this example, it says at noon, ship A is 30 nautical miles due west of ship B. Ship A is sailing east at 17 knots, and ship B is sailing north at 22 knots. How fast in knots is the distance between the ships changing at 9 p.m.? Note, a knot is a speed of 1 nautical mile per hour, blah, blah, blah. Okay, let's take a look here. So, ship A is west of ship B. Ship A is going east. Ship A is going east. Ship B is going north. Okay, so let's get this right. So here's ship A, and here's ship B. Right? A is to the west, and so connect these guys, straight line, and where's ship B going? So ship A is saying east, ship B is saying north. So yeah, okay. So right, this is north, south, east, west. Remember the directions. So it says A is to the west. How far is A? 30 miles west. So we'll just say this is 30 from there to there. It started out 30 miles west. Nautical miles are just, they're nautical miles. And ship A is sailing east. Okay, so ship A here is heading this way. So it's kind of going this way. And it's going at a speed of 17 knots, which is basically 17 miles per hour, nautical miles per hour. That's what a knot is, 17, sailing east. So it's going towards ship B. But ship B is sailing north. And it's sailing north at 22 miles per hour. Okay, and then they talk about the distance between the ships. So let's draw that on the picture as well. There's the, right, because this ship stops right here and this ship stops right here. And they'll call this Z. This is the distance between the two ships. Okay. And I always end up calling this will be X, this will be Y. From there to there, we always end up getting those numbers. And X, so here, let me stick that X right in, just it's easier to see. Maybe I'll change the color even. X, there to there is X. Okay, so let's get to our steps. Step number one, find, identify, spot the rate variables. I'll say letters. So what are the rate letters? Well, what do they say? Ship A is sailing east 17 knots. That's a rate. So what is that? That's Y. That's how fast Y is changing. They're telling us that dy dt is negative 17 because it's decreasing. Do you see what I'm talking about there? Y is how far from where the ship is now to that central point, and that's shrinking. It started off 30 miles away, nautical miles away, but it's going towards that at 17 miles per hour, nautical miles per hour. So that means the Y, which is the distance from where the ship is to that central point, is shrinking by 17 miles every hour, decreasing. And then X, they speak of X as well, the other rate, 22 knots, dx dt is growing, increasing, right? What is X? X is how far from that central point up to where the ship currently is, and that's X, and it's growing by 22 miles every hour because ship's going north at 22 miles per hour, so it's increasing. The distance of X, the distance this ship is from the central point, is growing 22 miles every hour, and this distance Y is shrinking because it's coming this way by 17 miles every hour. Okay, and then dz dt is what they want us to find, which is the distance between. That's what they say. How fast is the distance between the ships changing at 9 p.m.? So this gap between the ships, right? As this ship goes this way, this ship goes this way, this line is changing. It might be probably getting bigger. All right, so find the rate letter, step one. Step two, write an equation relating only those letters. You can use other numbers, but no other letters. Only those letters in this case. That's X, Y, and Z, just the rate letters. Well, that's pretty easy, right? That's obvious. X squared plus Y squared is Z squared. Our friend, the Pythagorean theorem, right? So X squared plus Y squared equals Z squared. There's our equation relating them. Step three, d dt, both sides. So I'm going to come in here and go, okay, I'm going to go d dt of this side and d dt of that side. All right, you know the deal. Bring down the 2x dx dt is 2y dy dt is 2z dz dt. Okay. Step four. Here, I'll stay with the same color. So step four is plug in the numbers. Plug in the numbers. First thing we can do, right, is we can just divide through. Divide by 2, divide by 2, divide by 2. Both sides of the equation. Divide everybody by 2, get rid of that. Okay. So now we just need x, y, and z. So how do we get x, y, and z? Go back to the original diagram. We can find them because of the movement. So let's start with x over here. X is going to be 22, right? Because it's going up this way at 22 miles every hour. And it's been doing it from noon to 9 p.m. That's for 9 hours. Times 9. It's gone 22 miles an hour for 9 hours. So how many miles has it gone? It's at 180 and 18, 198 miles, nautical miles. At 180 and 18, 190, yeah, 198 miles. So X is 198. So that ship has gone 100. Yeah, don't confuse the 20. The 22 is its speed. It's going up at 22 miles per hour, but it's gone a total of 198 miles north in the 9 hours from noon to 9. And what is Y now? Y started out 30 away, but it's closing the gap at 17 miles an hour. And it's been doing it for 9 hours. Oh, it's more than closed that gap, hasn't it? Oh, I didn't think about that. So in actuality, yeah. So how far is Y going to go? It's gone 17 miles an hour for 9 hours. What's that? 90 and 63, 153 miles east, right? That's what it said there. It says, where was it? I'm getting lost in this. Okay. Ship A is sailing east at 17 knots, 17 miles per hour for 9 hours. Multiply that, 90, 63, 153 miles east. It's got 150 miles. Now that means it'll cover this 30 and go a whole bunch more to the right. So Y is actually going to end up on the other side, isn't it? So it's going to, and how far is it going to be? It's going to be whatever 153. It's going to take away 30. It's going to be 123 miles to the east. So in reality, Y is going to end up, let me see if I can draw it, way over here. So this is where, right? And the total distance Y is going to be, you kind of messed everything up there, huh? Okay, Y is going to be right here, from here to here. Y will be 123 miles to the east. And so everything else is still true, all the equations we did. It's just they'll be like this. This will be the distance right here. This will be Z, which is the distance between the ships. So in other words, what's happened is from noon to 9, ship A went all the way over there, 123 miles to the east of that intersection point. How do I know? Well, it traveled 17 miles per hour. What's its knots? Time for 9 hours, it's 153 miles. So it covered the 30. It's 30. It started out 30 miles to the west. It covered the 30 and did 123 more. That's how it did 153, covered the 30. Now it's 123 to the east. That's 123. This ship has been going up. It's 198 miles to the north. And now Z is the distance between them. All the equations are still the same. It's just over here on the right side. So I got X, Y. Now, how can I get Z? Well, you know the deal. X squared plus Y squared is Z squared. So I got X, 198, plus Y, 153 now, equals Z squared. So finish solving for Z, square root. So that's what Z equals. The square root of 198 squared plus 153 squared. Okay, it's coming on down. What's X? X is 198 times dx dt. What's dx dt? Over here. 22, positive 22, because that's growing. And then y is 123. Y is 123 miles away from the intersection. And then dy dt. Oh, wait a minute. Hold everything. This dy dt is going to actually be increasing, isn't it? I got to make that positive. This is increasing. Do you see what happened? That does change because over here, when y was coming this way, it was decreasing the distance. But now, after that, now it's increasing. If y is the distance from the central point, which it is, that's how I wrote it, right? Y is how far from the central point to where the ship is. That is now increasing at 17 miles every hour. So after it passes the middle, all after that, y is increasing at 17 miles every hour. So at 9 o'clock, right? Right at 9 p.m. anyway, it's way over here, and that distance is just increasing. So positive 17. This is a little tricky problem here. Equals. And then Z is this square root of 198 squared plus 153 squared. 198 squared plus 153 squared. And then finally, dz dt. All right. Let's wrap her up. Let's divide both sides. Wow. Square root of 198 squared. It's 153 squared. 153 squared. Boom. All right, Desmos to the rescue. 198 times 22. Let's go. 198 times 22. Okay. 198. Oh, wait, I need a fraction here. No, let me clear that fraction. 22. 198 times 22. Plus 123 times 17. Plus 123 times 17. 123 times 17. 123 times 17, right? Over square root of 198, 153. 198, 153. 198 plus 153. There we go. 25, 7647. 25, 7647. So 25, 7647 is dz dt 25, 7647. And we got a different answer. That's disappointing. After all that work. Shoot. 25, 7647. Did we make a small mistake? 198, 153. Oh, is y supposed to be? No. 198, 123. That's right. 198, 123. Oh, what right here. Y should have been 123, huh? 120. I don't know why I grabbed 150. It's 123. There's my mistake. Oh boy, that's dumb. Sorry. That should be 123, not 153. Okay, let's go put that in 123. 123, 123. Let's go see if we can put that in and get that answer right. 123, not 153. 123. Okay, 27, 6583, 27, 6583, 27, 6583, 7, 6583. Is that the answer? Ah, that's better. We got it. All right. That was kind of terrible, wasn't it? And I messed up right over here. Sorry about that. That Y is 123, not 153. Whew, that's a tough one. That feels like calculus. All right, there we go.